Hello, welcome back. This is section 10, or chapter 10, section 2. We're going to be talking about arc measures and how to find them. So to start off, I want to add some vocabulary. A central angle is an angle whose vertex is the center of the circle. Now, when I'm trying to find arc measure, I need to know that my arc measure itself will equal the central angle measure. So arc measure will always equal the central angle. So I have three different types of arcs that I can define. I have the minor arc, which is an arc with a measure less than 180. And I have an arc of a major arc that's more than 180. And then, of course, I have another one that's called a semicircle. Also called a half circle. And this is going to equal 180 degrees. This is always created by the diameter. So I have three different names that I can give my arc depending on what it's looking for. I can do a minor arc, a major arc, and a semicircle. Moving on from there, how do we find the measures of the minor and major arcs? So to start off with, I need to fix something. Get rid of that C. But to start off with, I want to go ahead and highlight my minor and major arcs. So this would be my minor arc, arc AB, and we represent minor arcs with two letters. My major arc is going to be coming all the way around, and it's represented by three or more letters. This just tells us which direction to go in. So since it says ADB, I'm going to follow the ADB pattern. Moving on from there, I have a couple examples that I want to go ahead and do to practice this. So I'm going to go ahead and write out the arcs that we're going to find. So first things first, we're going to find the measure of RS. We're going to find the measure of arc RTS. And then we need to find the measure of arc RST. So if I want RS, I want this lovely minor arc that's right here. And that just gives me the same as the central angle, which is 110. Then I want RTS, so coming around RT and then S. That's everything except that 110, so that's going to be a 250. Because we do know, or if we don't, we need to know that a circle is equal to 360 degrees. And then finally, I have RST, so I'm going to follow this, RST. It gives me 180 degrees. And that is finding my arc measure. So let's go ahead and do one more example. We're going to find some other ones here. We're going to find the measure of arc GE. I'm going to want the minor arc of GE since it's two letters. I want the measure of arc GEF and the measure of arc GF. So GE is going to end up being 40 plus 20 because I want this minor arc, 40 plus 80, which gives me 120. My next one is going to be GEF, so I'm going to come all the way around, which gives me 120 plus 110, which is 230 degrees. And then finally, GF, which is this little sliver on the other side, so the part that I haven't used yet, and that's 130 degrees. Okay, moving on from there, I want to add a couple more definitions in. Congruent circles are going to be, two circles are congruent if and only if they have the same radius. So I can only have a congruent circle if the radius is the same. Now, congruent central angles theorem states that if a circle, or if the same circle, or incongruent circle, so it can be either, two minor arcs are congruent if and only if their corresponding central angles are congruent. So looking at this lovely picture, would be an example of the same circle. Because the arcs are, because the central angles are congruent, the arcs are congruent. Now, this goes back to something similar as our our congruent triangles unit. And we talked about how you cannot just prove triangle congruence by angles alone. And that's the same thing here. And we're going to talk about arc length later on, but the length may not be congruent just because the central angle is. The measures are going to be congruent. And so that's why we have to prove, if we have two different circles, that those are congruent circles first, because they have to be the same size to have the congruent arcs. So I have a little bit of a step here that we can use to figure out, do we have congruent arc measures? So the first step here is, do you have congruent circles or the same circle? If you have either of those two options, you'll move to step 2. If neither of those are true, then you're done. Arcs are not congruent. Step 2 states that, are the central angles congruent? Yes, then continue to step 3 and you'll get your answer. No, then the arcs are not congruent, because we have to prove I'm either in the same circle or I have congruent circles first, and then we have to make sure those central angles are congruent, because that's what our definition tells us to do. Then finally, if all of the previous ones are yeses, then arcs are congruent. So looking at these two problems here, looking at this first one, I'm trying to determine if the red arcs are congruent. In this case, I have the same circle. So I have same circle. And I have congruent central angles. So it is yes because of that. So looking at part B of this example, I need to look here and say, do I have congruent circles or the same circle? Well, I have two different circles here, and looking at these, one is inside the other. That's going to be the radius of one. The other one's going to be slightly larger. So no, I cannot even move to the next step, because the circles are not congruent. Now, just because the central angles are congruent does not mean the circles are. And so I cannot claim those arcs are congruent if the circles are not congruent. Okay, and that is talking about arc measure. Come back for the next section where we talk about chords.